In a stress-strain curve, the slope of the linear part is called Young's modulus, which describes resistance to elastic deformation under load. Steep slope means a stiff material. For example, diamond is a very stiff material because it has high Young's modulus, and it changes its shape only slightly under elastic loads. That is to say, diamonds requires high loads to elastically deform. Beware, stiff material doesn't mean strong material, which requires high load to permanently deform or break it. The opposite of stiff is flexible. For example, a rubber band is flexible because it has low Young's modulus and it changes shape considerably. In this chart, the more right it goes, the higher Young's modulus a material will have. Rubbers have lowest Young's modulus. Polymer forms are also very low, for example, sponge and yoga cushion. Other polymers such as plastic, epoxy resin, hair, and nails will have higher Young's modulus. Woods are probably the most common materials out there, and some World War II airplanes were made of woods. For example, de Havilland mosquitoes use a lot of hardwoods such as Canadian yellow birch and softwood such as Sita spruce. Next is composite. Carbon fiber and fiberglass are probably the best non-composite materials. Metals and alloys are very stiff materials, such as aluminum, iron, steel, magnesium, and titanium. But the stiffest material is ceramic. Glass, diamond, porcelain all fall into this category. Although ceramic materials are the stiffest, they break easily because they are brittle. The opposite of brittle is ductile. So what do brittle and ductile means? If a material undergoes large amount of plastic deformation before fracture, the material is considered ductile. For example, we want a bridge to be ductile because the high toughness associated with ductility allows bridge to absorb energy under high loads. Also, being ductile allows the bridge structure to bend and deform without rupture. Spring steel, mild steel, aluminum alloys, gold, and silver are very ductile materials. The opposite of ductile is brittle. A brittle material breaks at very little deformation. You can actually tell if a material is ductile or brittle by looking at fractured surfaces after they have broken. Ceramic, cast iron, and concrete are very brittle material. Taking bridge as an example again. If a bridge is made of plain concrete, it can support heavy weight because it's strong in compression. However, it can still break due to its low tensile strength when subject to stretching, which is tension. During a violent earthquake, a concrete-made bridge can collapse because it's too brittle. Some materials can go from ductile to brittle when temperature is lowered. For some steels, this transition can happen around 0 degrees Celsius. Ductile to brittle transition temperature is important in design consideration since brittle failure is normally less preferred than ductile failure. The most famous example is Titanic. The icy water of the North Atlantic Ocean was around -2.7 degrees Celsius. The low temperatures caused the steel of the ship's hull go from ductile to brittle, resulting in catastrophic brittle failure. Another example I want to give you is landing gear. Winning the level of troposphere, the atmospheric temperature decreases as the altitude increases. When an airplane flies, its temperature can be -40 degrees Celsius, which is way below the ductile to brittle transition temperature of many steels. If a landing gear becomes brittle, it could shatter upon the impact of landing. Engineers need to find a material for landing gears to remain ductile under low temperature. Without reliable landing gear, airplanes are useless. Many planes use 4340 alloy steels as the material of landing gear main cylinders. Thanks to its unique blend of carbon, chromium, nickel, and molybdenum, 4340 alloy steels doesn't have a sharp ductile to brittle transition and it remains ductile down to -100 degrees Celsius. It has high strength, high toughness, and good fatigue properties. If you like this video, please hit the subscribe button and leave the comment below. It will be very helpful. Thank you for watching.